selecting the material number 2 for design of the pressure vessel. So substitute the value of material number 2 in the equation of the mass of the vessel and in the equation of the stress. So here once you substitute the m value, rho value, so we are going to get this equation in terms of d square and t. And if you substitute value of sigma t means it is SUT by FOS, and if you substitute the value of P, so here also we are going to get the equation in terms of D and T. So two equations and two unknowns. So if you solve this equation, so we are going to get the value of D, we are going to get value of D, and we are going to get value of the T. That is D is equal to, that is 1.05796 meter. It is equal to 1057.96 mm. Thickness is so 12.7 mm, and if you substitute this value of D and T in the volume, so you are going to get the, that is equal to, otherwise you can substitute the SUT and rho. So you can substitute SUT and rho. So we are going to get the volume is 0.62 meter cube. Okay. So this is about the solution of the problems. Okay. So till now whatever you have seen the problems. So this type of problems normally it will be asked in the exams. Okay, so whatever these problems we have solved, so these belongs to the, that is, so you can see, so one concept I am going to explain here. So categories of optimum design problems. So here optimum design problems we are going to classify into three types: normal specifications problems, redundant specification problems, and incompatible specification problems. Whatever problems we have solved, so they are normal specifications problems. Normal specification problem means, so here whatever we have done here, suppose we have formed the primary design equation, we have formed this secondary design equations. So suppose if we are able to substitute the secondary design equations in primary design equations, suppose let us say secondary design equations are not having what you can say diameter notation. Suppose there is no diameter mentioned in the secondary design equations, so we cannot substitute in the primary design equations. So in that case it is not the case of normal. Okay, so if we are able to substitute this secondary design equations in primary design equations, so then it is called the normal specifications. Suppose if we are not able to substitute secondary design equations in primary design equations, so then it is called the redundant specifications optimizations problems. Okay, so if incomplete data is given, so if we are not at all able to develop the relations between different parameters, so then it is called the incompatible specifications optimization problems. Okay, so whatever we have solved, so they are normal specifications problems. Normally problems comes on these concepts, and theory questions comes on this redundant specifications. Okay, so you prepare for the theory question on this, and question may also come on the difference between normal specification optimum design problems and this redundant specification optimum design problems. Okay, so some of the important theory questions I have listed here, so which will normally come in the exams. So you prepare these theory questions. So if you have any doubts, so you can get back to me through the different platforms. So first question is, explain design parameters with respect to optimum design. So this is already we discussed that. Okay, so that is primary. What are the design parameters? So these are the different design parameters, that is functional requirement parameters, geometrical requirement parameters, and material requirement parameters. Okay, next is second question, explain adequate design and optimum design. So this is just I explained in this starting of the slides at the start of the this video. Next question is, differentiate between adequate design and optimum design. Okay, so just to differentiate, so by understanding. So next question is, explain different types of equations that are used in Johnson method of optimum design. So this is, you need to explain three types of equations, that is primary design equations, subsidiary design equations, and limiting equations. Okay, next is explain Johnson method of optimum design. So here you need to explain any one method, that is Johnson method for normal specifications and Johnson method for redundant specifications. For both you need to explain how to use this method to solve the problems of optimum design problems. Next is explain the procedure of solving the optimum design problem with redundant specifications. So just previous slide I told you that normally theory question come on the redundant specifications, so you prepare for this question. So next is differentiate between optimum design problems with normal specifications and redundant specifications. So normally this question will also come in the exams. And one more thing I want to tell you that, so minimum you solve the minimum 5 to 6 question paper problems, previous SPPU question paper problems, whatever that belongs to this unit, optimum design. Okay, so if you prepare this much, so it will be good for you. Okay, so if you have any questions, so you can get back to me. So also I want to tell you, so I am going to share some questions, like quiz type questions on this unit. So you just answer that questions. So I am going to share that link. So in the form of, that is what you can say, that is in the form of the Google Forms. Okay, so that you just answer that questions, so that will make you more and more clear of this unit. Okay, so they are simple questions, so I want everyone should solve the questions by going through that link. So probably, so I am going to share that link on the Tuesday, that is on the 24th of March in the morning. Okay, so you answer all the questions. So if you have any doubts, any questions, so if you want, if you require any material, so you can communicate with me so that I can clear your doubts. Okay, thank you.